Good day, organic chemists. We are going to be doing organic chemistry. So, of course, here you can see that we are given a table. Remember that we are asking ourselves a question as to what type of questions, of course, they're going to ask in the preliminary examinations. What type of questions they're going to ask in the final examinations. The good news is that, of course, you are done with content. Now it's about time you do a lot of questions, of course. So, now here you are given a table, and of course they say write down the IUPAC name for compound A. So what we are recognizing and realizing is that we are doing what we call organic chemistry. But I have a question for you. What is organic chemistry? Perhaps let us try to answer that question first, which is what exactly are we even talking about when we talk about organic chemistry? So, halala right now. Now, I want you to understand that, well, when we talk about organic chemistry, by definition, well, we are talking about the classification of organic compounds. There are thousands, if not millions or billions of these organic compounds. So we must have the ability then to classify them. Classification of organic compounds. So in terms of your examination, this is perhaps the most simplest part of your chemistry examination, because all you will have to do is to be able to classify these different organic compounds, and by memory I believe you'll be able to do that. You know what is an alkene, for God's sake, you know that. So halala right now. So not only do we classify these organic compounds, so what we also look at in terms of these organic compounds is, of course, the physical properties. To say, well, we have alkanes. Now we are able to classify them, but we are interested in their physical properties. To say, how do alkanes behave, perhaps compared to alkenes, perhaps compared to alkynes? That's just what we are interested in here. So, halala right now. To have the ability, of course, to classify compounds, to have the ability, of course, to look at the physical properties of these organic compounds. Unfortunately, we are not done. There's quite a lot of work that we are supposed to do, of course, with these organic compounds that we are going to learn of and about under organic chemistry. So I want you to understand that in actual fact, organic chemistry is a language on its own. So halala right now. So now that we've discussed as to what is organic chemistry, the last thing that I want us to focus on then as to what is organic chemistry, we are going to recognize and realize that organic chemistry is all about the reactions and, of course, their mechanisms. Now, this is where, of course, most learners have a bit of problem when we talk about reactions of organic compounds. It's a bit problematic. So we're gonna delve into these reactions and try to see what exactly are we interested in when we talk about the reactions of organic compounds. And of course, we are not only going to be focused on the reactions, but we're also going to talk about the reaction mechanisms, the procedures, the processes behind these different reactions that we are going to talk of and about. Addition, elimination, so halala right now. So please know that chemistry is about classification of organic compounds. You must have the ability to classify organic compounds. We must learn their physical properties. We must learn their reactions. So in this specific video, we are going to focus specifically on the classification of organic compounds. So halala right now. So let's see what type of questions they talk of and about under classification of organic compounds. Now for the first one here, they say write down the IUPAC name for compound A. You are an organic chemist. You know what is an IUPAC name. Specifically for compound A. Well, compound A is a little bit shrink there. So let us go to the one that I drew here and try to see how can we be able to find the IUPAC name. So of course there are a bit of procedures, processes, steps that we have to be able to use in order for us to be able to name these compounds or these organic compounds. So we are having a very horrible looking organic compound here that we must have the ability to classify by giving its organic name or its IUPAC name. So usually the procedure that we say let us use in order to be able to name these organic compounds, we say, well, how about we draw a bit of a table like this, and at the center of this table we will have what we call the base. well, not the base in terms of what we are going to learn in acids and base, but let us say here we have the base in terms of the number of what? The number of carbon atoms, present in the longest chain, of course. So the longest carbon chain, so we say, so halala right now. So we are going to look at the base at the center and have the suffix here. And then we're going to have what? We're going to have the prefix somewhere here. Pre meaning coming before, of course. Prefix. I hope you understand English. So let us identify the base first. That's what we usually say. How about we try by identifying the base first? Because with the base, we are only interested in the longest carbon chain. Matriculants, never, ever do a mistake, of course, of thinking this C there will be part of the chain. Because trust me, a lot of students or a lot of learners have that tendency, and they snacks, C's. Yes. So never ever do that in Fanaboso and think the C there is part of the chain. That is chlorine, not carbon in any way, howsoever. So now let us try to find the longest carbon chain. I hope you can agree with me that the longest carbon chain, of course, is the one that I've just highlighted there. So now we are concerned as to how many carbons in the longest carbon chain. Perhaps let us change color here and say, well, we are going to have, this is NUX. We are going to have, let us see, we are going to have carbon, this will be our carbon 1, this will be our carbon 2, this will be our carbon 3, our carbon 4, and then this one our carbon 5. So that is how we're gonna name the carbons. So from the fact that we are looking at the base, we can agree that at this time and moment in Fanaboso, with the base, it tells us the parent name as to how many carbons we find in the longest carbon chain. 1, 2, 3, 4, 5. So that means somewhere in the name that I'm going to use for this organic compound to classify, I must see pent somewhere. It's a must, it's a necessity, because there are 5 carbon chains or rather there are 5 carbon atoms in the longest chain. So right now we've identified the base. Now we are going to try to identify the suffix. The suffix is the ending to say what functional group. So that is what we ask ourselves here. What functional group, of course. So here we can see that we only see single bonds. Nowhere whereby you see, of course, double bonds or triple bonds. So for single bonds, we say those are saturated. Single bonds, therefore, usually mean alkanes. So all alkanes are in actual fact single bonds. All alkanes are definitely saturated. But immediately we start to talk about double bonds, triple bonds. Those are what we say are unsaturated. We're going to talk about that in Fanabo. So it's part of organic chemistry. So halala right now. So we see that we're going to have pentane somewhere. Now, in terms of what? In terms of the prefix. The prefix, we are interested in the branches. Remember, a tree has branches. So what branches or what substituents do we have? What attachments do we have there? So we can see the first attachment, which is chlorine, and it is on carbon number 1. So somewhere, somehow in our name, we must have 1 chloro. So they sound scary, but so somewhere, somehow in our prefix, somewhere, somehow in our substituents, we have what we call 1 chloro. So halala right now. But that's not the only substituent that you see there. Here is a substituent. Here is another substituent. Then we have 2 substituents or 2 branches, which of course are both methyls. So we will have what we call dimethyl, because we have 2 methyls. If you say methyl or methyls our cis. Now of course you must be able to say dimethyl, at least you are a chemist. So halala right now. So here we can see carbon 2 bears a branch, carbon 3 bears a branch. So we're gonna have 2.3 dimethyl. That is what we are going to have, therefore, as part of our what? As part of our prefixes. So we have 2 prefixes, which is 1 chloro, 2,3 dimethyl. That's what we have. So the name, therefore, it's nice now. The strategy that we've used seems to be nice because we can be able to name this compound 1-chloro 2,3 dimethyl pentane. Ke 3 marks ya gago mfana boso ya mahala wa ibona taba mfana boso halala right now. So we've gotten our 3 marks. We've done question 1 yuta halala right now. Now mfana boso, question 2 says write down the letters of the compounds that are functional isomers of each other. So we have to ask ourselves a question, which is what are functional isomers? Now, before we even talk about what are functional isomers, it is worth mentioning that we have different isomers, or in this concept of isomerism. It sounds nice. Isn't chemistry nice? Oh, sis, I'm not DDD. So, isomerism, we have to know what are functional isomers. We have to know what are positional isomers. We have to know what are chain isomers. We also have to know what are structural isomers. Those are type of isomers that we must know under isomerism. Please don't tell me you are traumatized. This is the first time you hear the word isomerism, because in actual fact, when you talk about positional isomers, chain isomers, structural isomers, functional isomers, you are simply talking about nothing else but what? But isomerism. So from the table that we have, we can try to compare B there with E, because what you're going to realize about B and E is that they have what we call the carbonyl. So the only best way for you to understand isomerism, to be able to try to classify compounds as isomers, do you see that this is still part of classification aspect of organic chemistry, because you are trying to classify functional isomers. Now, by definition, according to the examination guidelines, which you must know by heart and soul before you go to that examination, is that the functional isomers have the same molecular formula. Same molecular formula, but different what? But different functional groups. Same molecular formula, but different functional groups. So it's self-explanatory. Functional isomers. In fact, when we talk about isomers, they always have the same molecular formula, but different this, different that. For functional isomers, we will have different functional groups. So these two here, B and E, are the solution. So the solution for this one, of course, will be B and E. That is the solution that we will have for number 2 as functional isomers. So halala right now. So we've done number 2. So let us go to number 3. Number 3 says write down the letter for the compound that is classified as a tertiary alcohol. So of course you have A, B, C, D, E, F. So you will try to eliminate anything and everything that is not an alcohol, and of course you will be left perhaps with B and you will be left with D and F as alcohols, propanol and 2,3 dimethyl pentool. You have to balance yourself when you pronounce these organic compounds. So for us to be able to give the letter of the tertiary alcohol, perhaps we must ask ourselves, what is even a tertiary alcohol? Well, the analogy that I could use here is that, well, when you are in primary school, here you are, when you are in primary school, you only have a report to show. Our wiki blind, you only have a report to show. In actual fact, let me change color for that. When you are in primary, you only have what? You only have one thing to show, which is a report. Academically, hauna value academically. But once you start to go to secondary, at least now, not only are you going to show us foundation phase report, intermediate phase report, senior phase report, you can even show us an FET report. So at secondary level, at least now, you will be having 2 things to show us. Perhaps you will show us your metric, or rather, you will show us your what? Once you finish secondary, you will be able to show us your grade 7 report, you'll also be able perhaps to show us your matric certificate, which is what we are going to do as organic chemists soon, because you are going to get your matric certificate very soon. You'll be having, academically, you'll be having a bit of value. You can use your matric certificate and of course your primary qualification, which of course helped you to get to your secondary qualification. So secondary means you only have two pathways. In terms of carbon, it means carbon only have two carbons attached to, if we have an alcohol somewhere here in the carbon, we will have other two carbons, of course, that are going to go to the side and perhaps a hydrogen. So now if you go to tertiary, you now have a bit of more value. You have your primary qualification, your secondary qualification, which is matric, and even your tertiary qualification. Now you have a bit of value academically. You can go this way, that way, or that way. There are three paths. In terms of carbon, we can say there are three carbon chains. So this which we have here then will be a tertiary alcohol, or for this specific carbon that we have here, we will call it a tertiary carbon, given that it is attached to other carbons here. If it is attached to something else, then it's another story. But if it is attached to other carbons, those are the pathways that we are talking of and about. And here we know it will be hydrogen again, because carbon must always have 4 bonds around it. So halala right now. So the tertiary alcohol there, if you try of course to draw the structural formula, so usually having the structural formulae helps you a lot in being able to classify these organic compounds, because now you have their structures. What will stop you from being able to classify them? So halala right now. So in this particular question, the solution of course will definitely be F. F will be our tertiary alcohol. So when you progress with your chemistry journey, you'll see that they write something like this, 3 and a bit of something like degrees, which simply means it's not degrees as such, but it simply means nothing else but tertiary in this regard. So this will be a tertiary alcohol. I hope you are able to determine primary, secondary, and tertiary alcohols, because it is in actual fact part of your learning objectives according to the examination guidelines. So that's just how you get another 3 marks for free, because you are interested in nothing else but the classification of these organic compounds. Now you are classifying this organic compound to say, this one is a tertiary alcohol. So halala right now. So I would like you to mize question 4. It's weird. It's very wrong. It was a matter of typing error here. Of course, what the question is actually saying is for you to be able to give them the structural formula of C. You can see that it looks very weird. So as a challenge question, I would kindly like you to please, of course, try question C 5.6, and of course you can comment it on the comment section, and of course I'll get back to you with a response for the structural formula for number C. So halala right now. Welcome to Science Intellect Hub. My name is Mr. Mojaki Sanese. They call me Mr. M. So halala right now.